Octal to binary conversion. The long method to convert an octal number to binary number is to convert it to decimal number and then convert the resulting decimal number to binary. Using our previous example, we already know that 7041 octal is equal to 3617 in decimal. So, we already have the first step done for us. To complete the process, we will now convert 3617 to binary. Using the process explained, we will get 3617 divided by 2 equals to 1808 remainder 1. 1808 divided by 2 equals to 904 remainder 0. 904 divided by 2 equals 452 remainder 0. 452 divided by 2 equals 226 remainder 0. 226 divided by 2 equals 113 remainder 0. 113 divided by 2 equals 56 remainder 1. 56 divided by 2 equals 28 remainder 0. 28 divided by 2 equals 14 remainder 0. 14 divided by 2 equals 7 remainder 0. 7 divided by 2 equals 3 remainder 1. 3 divided by 2 equals 1 remainder 1. 1 divided by 2 equals 0 remainder 1. So this means that 7041 octal in binary is 1110001000001. To check, let's do a reverse conversion from binary to octal. Group the binary strings into sets of 3. This will do like this. And then get the octal equivalent of each group. The octal equivalent of each set is 7041 and it's equals to 7041 octal. So this means our binary number is correct. I have a downloaded video which will show you some examples on how to convert octal to binary.
In this video, we're going to talk about how to convert an octal number into a binary number. So let's say if we have 56 in the base 8 system, that is in the octal system, how can we convert that to a number in the binary system, that is in the base 2 system? So what you want to do first is separate the 5 and the 6. Now you want to break it down to these numbers, 4, 2, and 1 for each one. 2 to the 0 power is 1, 2 to the first power is 2, 2 squared is 4. Now, to convert 5 into a binary number, you need to realize that 5 is the sum of 4 and 1. So because we used 4 and 1, we're going to replace that with a 1. We didn't use 2, so we're going to replace that with a 0. Now, 6 is the sum of 4 and 2. Since we used the 4 and 2, we're going to replace that with a 1. We didn't use the 1, so let's replace that with a 0. So 56 in the octal system is equal to 101110 in the binary system. And so this is the final answer for this problem. And that's how you can convert a number in the octal system to a number in the binary system. Now let's try another problem. So let's convert 35 from the octal system to a number in the binary system. If you want to pause the video, feel free to do so and try this problem. So let's begin by separating the 3 and the 5. Now let's write the numbers 4, 2, 1 for each. Now 3 is the sum of 2 and 1. So we're going to replace 2 and 1 with a 1, and we didn't use the 4, so let's replace that with a 0. Now 5 is the sum of 4 and 1. So let's replace 4 and 1 with a 1. We didn't use a 2, so let's substitute that with a 0. And that's it. So 35 in the octal system, we can write it as, now here's the question, should we write it as 011101? Now, if you have a 0 in the front, you need to get rid of that 0. So therefore, we only need to use these 5 numbers. So the answer is going to be 11101. So watch out for that. So this is the answer. Now, if you want to check your work, here's what you can do. Let's convert the octal number into a decimal number, a number in the base 10 system. To do that, you need to multiply the 5 by 8 to the 0 and the 3 by 8 to the 1. So it becomes 3 times 8 to the first power plus 5 times 8 to the 0 power. 3 times 8 is 24. 8 to the 0 power is 1. So that's 5 times 1, which is 5. And so the sum is 29. Now, to convert the binary number into a decimal value, here's what you need to do. So the first number we need to multiply by 2 to the 0, the second by 2 to the first, and then 2 squared, 2 to the third, and 2 to the fourth. So we have 2 to the fourth plus 2 to the third plus 2 squared, and then 0 times 2 to the first power is 0, and then we have 1 times 2 to the 0. 2 to the fourth is 16, 2 to the third is 8, 2 squared is 4, anything raised to the 0 power is 1. Now, 16 plus 8, that's 24. 24 plus 4 is 28. 28 plus 1 is 29. So we get the same answer. Because these two are the same, we know for certainty that these two must be equivalent to each other. And so that's how you can check your work. For the sake of practice, let's do one more example. 643 in the octal system. Let's convert it to a number in a binary system. So the first thing we should do is separate each digit. Now to get 6, we need to add up 4 and 2. And so let's replace those numbers with a 1, and then the other one that we didn't use, replace it with a 0. To get 4, all we need to use is 4. So this is going to be 1, and then we didn't use the other numbers, so 0 for the 2 and 0 for the 1. Now to get 3, we need to add up 2 and 1. So that's going to be 0, 1, 1. And thus we can see our answer right here. So 643 in the octal system is 1, 1, 0, 1, 0, 0, 0, 1, 1. And so this is the final answer. So now you know how to convert a number from the octal system to the binary system.